topic is on logic. So let us start our discussion on what is logic. So it is a discipline that deals with the methods of reasoning, and it is the study of how to evaluate arguments and reasoning. So we have logic reasoning or logical reasoning. It is used on mathematics to prove theorems, to verify correctness of programs in computer science, and to prove theorems. So we have here what we call proposition. So proposition is a statement, or proposition is a declarative sentence that is either true or false, but not both. So here are examples of propositions. So 1 plus 2 is 4, which is a type of proposition, and the truth value of the example A is false. And we have example B, 5 is less than 11, and the truth value of 5 is less than 11 is true. We know that 5 is really less than 11. And on our example A, 1 plus 2 is actually 3. So the truth value of our example A is false. And example A and B are type of or classified as propositions. So we have here the truth value. So it is the truth or falsity of a proposition. So it's either true or false, but not both. So here are examples. So can you tell which of the following propositions are true or false? If it is false, state why. So 9 is a prime number. Is it true or false? So our answer is 9 is a prime number. It is false because it is a composite number. Okay, again, a prime number is a number that its factor is itself and 1 only. So another example, so 5 plus 3 is equal to 8. So we know using basic arithmetic that 5 plus 3 is 8. So it is true. So now, example number 3, we have x squared plus y squared is greater than or equal to 0. So our solution, it is true. Because if you're going to square a number, it is always positive. So the least value that you can get on x squared is 0. And same as true with y squared. So 0. If you're going to add two zeros, that will be 0. So it is still true. 0 is greater than or equal to 0. We have here another example. Example number 4. So we have 10 is less than negative 3. So 10 is less than negative 3 is false because 10 is greater than negative 3. So we have here propositional variable. It is a variable which is used to represent a proposition. So formal propositional variable, it is written using the propositional logic notation such as P, Q, and R are used to represent propositions. So we have here logical connectives. So it is the mathematical equivalent of a conjunction in English. So it is and it is or. So we use this symbol, the inverted V, or there is a and for or it is V. So we have compound proposition. It is a proposition of two or more simple proposition connected by logical connectives. So we have here truth tables. A truth table is a table that shows the truth value of a compound statement for all possible truth values of a simple proposition. So let us have an example for conjunction. So the conjunction of proposition P and Q is the compound proposition P and Q, denoted as P and Q. So we have here the symbol for P and Q is this P and Q. So the conjunction of two proposition is true if both P and Q are true. Otherwise, it is false. So we have here the truth table for conjunction. We have P and Q, and then the combination of true and false. We have true, 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 false, false, true, and false, false. So ito yung mga possible values ng P and Q. And then we're going to evaluate kung ano yung truth value ng ating P and Q. Remember, kapag sinabi nating and yung ating operation, kailangan parehas silang true para maging true siya. Otherwise, it will be false. We have true and true. That's why ang sagot natin dito is true. When we have here true and false, it is false kasi mayroong isang false kasi kailangan natin parehas na true. And false, true, false. And then we have false, false. It is false. So for the conjunction, we have P and Q. This is our truth table. Example, write two statements into conjunction. Today is Friday for our P, and for our Q, it is Sunday. So the solution, today is Sunday and it is sunny day. For disjunction, So this disjunction of proposition P and Q is a compound proposition P or Q. It is denoted as P or Q using this symbol. So the disjunction of proposition is false when only or when both P and Q are false. Otherwise, it is true. In other words, kapag mayroong isang true sa ating disjunction or yung or na or na operator natin is considered true. So since this is both true, that is true, and we have true and false, that's why ang ating P or Q is true kasi mayroong isang true. And then we have false true. Here is still true kasi may true pa rin. And then we have false false. It is false kasi walang true. Remember, kapag or ang ating operator, it is considered true basta mayroong isa sa kanila is nag-true. Doon naman sa ating end, kailangan parehas sila na true. So example, write the two statement as disjunction. Today is Monday and it is raining today. The solution will be today is Monday or it is raining today. Remember, when we say conjunction, it is and if it is disjunction, it is or. So exclusive or, so another operator, exclusive or. When we say exclusive or, the disjunction or the disjunction exclusive or is true only when one of the proposition is true. Otherwise, it is false. So for example, students who have taken calculus or computing essentials but not both can take this class. Only those who can take one of them. So here is our symbol for exclusive or. So P exclusive or Q. So kailangan daw isa lang ang true. Otherwise, it will be false. So we have here true, true. It is false kasi it is exclusive or ang ating operator. True, false. It is true. False, true. True kasi mayroong isang true. And we have false, false. It is false kasi parehas. So for our exclusive or, kailangan magkaiba sila ng truth value. Or isa sa kanila will be true. So pag nagparehas sila, it is considered false. This is the truth value for our exclusive or. Summary of truth tables, as you can see. So we have here P and Q. So we have false, false, true, false, true, false, true, true for our end, for our conjunction. So kailangan magparehas sila na true para maging true. Otherwise, false. Okay, for our or naman, kailangan mayroong isang true para maging true. So we have PQ, true, false, true. That's why true ito. True, false, kaya true ito. And then we have true, true. That's why true. For our exclusive or naman, kailangan magkaiba sila ng truth value. Kailangan isa sa kanila is true. So you have false true, kaya true ito. We have true false, kaya true ito. And then we have true true, that is equal to false kasi they are the same as true with false false. It is false. So for negation naman, a statement is a negation of another. A statement is a negation of another if the word is not introduced in the negative statement. Let P, the proposition, the negation of P is not P, or using the symbol negative P. So for negation, so the truth value of the negation of a proposition is always the reverse of the truth value of the original proposition. So it will be the reverse. Kung positive siya, kinuha ang negation, this will become negative. Pag negative naman siya, kinuha yung negative, it will become positive. So for example, we have proposition P, A is consonant. For negative P or the negation of P, it is the case that A is not consonant. The following is the truth value for negation. So if P, proposition P, if true, the negation of P will be false. If P is false, the negation of P is true. For implications, so we have here, let P and Q are the propositions or statements. So the statement if P, then Q is called the implication or conditional statements. So it is denoted as P, arrow, Q, where P is the hypothesis and Q is the conclusion. So for the truth table of implications, we have here statement P and we have statement Q. So we have true, true, it is true. And if true implies false, it means it is true. If true implies, if false implies true, it is false. And if false implies false, it is true. So remember the truth table for implication. So for example, today is Sunday and Q, I will wash the car. So if you're going to write that in symbols, P implies Q. If today is Sunday, then I will wash the car. If, remember that implication is an if-then statement. If P, then Q. So the converse of this implication is denoted as Q implies P. If I wash the car today, then it is Sunday. So the inverse of our implication is negative P implies negative Q. It is the inverse. If today is not Sunday, then I will not wash the car. And then the contrapositive of this implication is that not Q implies not P. So if I do not wash the car, then today is not Sunday. So we have also biconditionals. So let P and Q be the statements. So we have the statement if and only if. So P if and only if Q is a biconditional P and Q. So we use double arrow to denote biconditional statements. And this read as P if and only if Q. The phrase if and only if can be written as IFF or if and only if. So for biconditionals, biconditional is known as good definition. So for a statement to be good definition, the implication and its converse must be true. Otherwise, it is not a good definition. So we have here, for biconditionals, kailangan parehas na value para maging true siya. So we have true, 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 and then we have false, false, true. If it is magkaiba, it will become false. This is the by implication or biconditional truth table. So for example, P, you can take the flight. P, you can buy a ticket. Then P, if and only if Q, you can take the flight if and only if you buy a ticket. So we have example, write the following statement into symbolic form using the logical connectives. Let P, the sun is shining, it is raining, and or the ground is wet. So if it is raining, then the sun is not shining. Answer. If it is raining, then the shine is not shining. So Q ang ating, it is raining, and then sun is shining is P. So it is not, kaya we write negation here. It is raining and the ground is wet. So it is raining and the ground is wet. So the ground is wet. This is R. If and only if it is raining and shining. So R, if and only if it is raining Q and it is shining P. The sun is shining or it is raining. So P or Q. So logic bit operators. So computers represent information using bits. So a bit is a symbol with two possible values, 0 and 1. By convention, 1 represent true and 0 represent false. A variable is called Boolean variable. Its value is either true or false. So it is a Boolean variable. Its value is either true or false. So bit operation replaces true by 1 and false by 0 in logical operations. So we have here the table for bit operations. So we have XY, 0, 0, 0, 1, 1, 0, 1, 1. So you have or. Remember kapag mayroong isang true na siya. So 0, 0 kaya 0. And we have 0, 1 kaya 1. 1 and 1 kaya 1, and then 1 and 1 kaya 1. Kasi true, true, 1. True, false, true. False, true, true. Kasi kapag end naman, kailangan parehas na true. Kaya lahat 0 except doon sa true, true. Yung 1, 1. And kapag exclusive OR naman, or XOR, ang magiging true lang is kapag magkaiba sila. So 0, 1, true. 1, 0, true. Kapag parehas, 0, 0, 0. 1, 1, 0. So yun. So definition, a bit string is a sequence of 0 or more bits. Length of its string is a number of bits in the string. For example, find the bitwise OR, bitwise AND, and bitwise OR of the following bit string: 0, 1, 1, 0, 1, 0, 1, 1, 0, and 1, 1, 0, 0, 1, 1, 1, 0, 1. So our answer will be here. I-arrange natin siya vertically, and then we are going to solve for, unahin natin yung bitwise OR. So 0, 1, OR. So kailangan mayroong isang true sa kanila para mag-true. So 0, 1, kaya 1 yun. 1, 0, kaya 1 kasi may 1. So 1, 1, still 1. 0, 1, 1. So 1, 1, 1, 1, 1 is 1, 0. 1, 0, 0. So walang 1 kaya 0. 1, 0. 1, 1, 1, 1, 1, 1. So for bitwise OR using this given, our answer will be 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. Okay? For our bitwise AND, kailangan parehas sila para maging 1, otherwise 0. So 0, 1, kaya 0 yun. 1, 0, 0. 1, 1, yung parehas, kaya 1. 0, 0, 1, kaya 0. So 1, 1, kaya 1 yun. And then 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, parehas, 1, 0, 1, 0. Kaya yun. For our bitwise AND, our answer will be 0, 1, 0, 0, 0, 1, 0, 1, 0, 0. And for our exclusive OR, kailangan magkaiba para maging 1. So 0, 1, yes, 1 kasi magkaiba. 1, 0, 1 kasi magkaiba. 1, 1, so 0 kasi parehas. we have 0, 1. So 1 kasi magkaiba. We have 1, 1. So 0 kasi parehas. 1, 0. So 1 kasi magkaiba. 0, 0. 0 kasi magkapareho. 1, 0. 1 kasi magkaiba. 1, 1. So 0 kasi magkapareho. And we have 0, 1. It is 1 kasi it is different. So we have 1, 0, 1, 0, 1, 0, 1, 0, 1, 1. So we're going to tackle binary numbers sa susunod na video. So for now, that's all for logic. Thank you.